Welcome to the third session, Current Advances in Animal Welfare Science. Our first speaker is Grace Fuller. Dr. Grace Fuller was born and raised in Cleveland, where she recently completed a PhD in biology at Case Western. At Case, Grace was part of a partnership between the university and Cleveland Metro Park Zoo that allowed her to complete her PhD in applied animal welfare science while working as an employee of the zoo. Her dissertation work examined the hormonal and behavioral implications of lighting design for the welfare of nocturnal primates in zoos. Grace.
Thank you. I'll go with this mic if that's okay. All right, well, thank you for having me. It's an honor to be speaking among this group of people. So I'm going to talk today about my dissertation research, and actually I sort of fled the country right after my dissertation was done, so this is my first chance to really share it with another audience. And I'm going to start with my big conclusions first, in the interest of being scared of running out of time. So basically what I just want to convince you of today is the importance of lighting for the welfare of animals in a captive environment. Obviously it's something that impacts nocturnal species more than others, but we're learning more and more about how light affects human health and other diurnal species as well. My second point that I want to sort of make along the way is that for species that might have sort of relatively inactive behavioral profiles, or that just don't suit themselves well to the sort of normal indicators that we use to look at welfare behavior, that looking at rhythmicity of behavior and looking at circadian rhythms might be another way to kind of get at the questions of welfare in those types of animals. So I'll start at the beginning. All behavior is temporally organized, and this enables organisms to maximize their fitness by allowing them to perform appropriate behaviors at the right time, like breeding and eating and that sort of thing. And in mammals, the master clock for the body is located in the hypothalamus, more specifically in a pair of nuclei in the suprachiasmatic nucleus of the hypothalamus. That rhythmically oscillate on about a 24-hour cycle, producing an endogenous rhythm that's about 24 hours in length. This rhythm is then entrained by elements from the environment, the most salient of which for mammals is light cues entering through the retina. And this produces the basic division in forms between nocturnal and diurnal species. Nocturnal foragers are well adapted for nighttime vision, such as this potto here. You can see he's got really big eyes. He's also got a higher ratio of rods to cones in the retina, rods being more sensitive to brightness. And then in this pygmy slow loris, you can see also the tapetum lucidum, the reflective layer behind the retina that serves to amplify light signals. And because they have specialized visual systems that make them quite sensitive to light, it's perhaps not surprising that research has repeatedly showed that high-intensity light suppresses behavior in these organisms. Historically, zoos have housed nocturnal animals under red lights, and the reason for this is the physiology of the retina. So rod cells are, the opsin rather, contained in rod cells, it has a spectral sensitivity that's shifted towards the blue end of the spectrum, but are also relatively insensitive to red light. And what this means is that if we house them under red light, we think it should look subjectively darker to them because their rod-dominated retinas aren't going to be as responding as much to the longer red wavelengths of light. So our general hypothesis was that although this had been the practice in the past, it seems to have changed in recent years. So we figured that lighting design likely varies between North American zoos and that these differences have implications for the behavior, circadian rhythms, and welfare of captive nocturnal primates. So we first wanted to look at that assumption, and we did a fairly comprehensive survey of housing practices for lorises and pottos in North American facilities, but I'll just focus on the results relevant to lighting. And so one of the questions we asked was how are light and dark phases created in the exhibit? And I'll just draw your attention to this value here, which is 65% of all the lorises and pottos living in North American zoos are housed on an artificially created reversed light cycle. And the purpose of the reversed light cycle is to render the animals active during our daytime by creating sort of an artificial night when there are visitors present at the zoo so they can see the animals up and doing things. The implication of this, however, because we want to be observing them during their dark phase, they are illuminated for humans to view them. And then when we're gone and it's our nighttime and we're enjoying the dark, they have even brighter lights on that are simulating daytime for them. So they're exposed to artificial light all 24 hours of the day, which you can imagine for an animal with a very specialized visual system might be problematic. We also saw that blue and red light are commonly used to simulate a nighttime appearance during the dark phase for nocturnal species. So just a little bit more facilities using red compared to blue. Again, this is for lorises and podos, but I think it probably applies to other nocturnal species as well. And you'll notice I don't have any information on light intensity. Most facilities really weren't able to provide that information or said that they didn't have the means to measure it. So there's a lot of reasons why we know that there's this link between light and behavior, but what's really fascinating is emerging information looking at the impacts of light on measures of health. And here you can see that we've really changed our light environment in a dramatic way by the invention of artificial lighting. Exposure to light at night is linked to a variety of medical and ecological issues. So nurses that work the night shift have higher rates of breast and other endocrine-related cancers. And circadian disruption is also associated with immunosuppression, cardiovascular disease, metabolic syndrome, reproductive suppression, all kinds of, sort of terrible things. And these are endocrine mediated, mainly by the hormone melatonin, which is secreted in greater amounts in darkness. So light is essentially an endocrine disruptor, and for this reason, the American Medical Association recommends against using blue light in the bedroom and recommends red, and the WHO actually categorizes shift work as a probable carcinogen. So I think of our podos and our lorises as the little shift workers of the zoo world. So we wanted to look at this question experimentally, which we did using 14 primates in 3 different zoos. Sort of a ragtag group, but it happens that way sometimes. We did actually work with the majority of the podos in the captive population, which is quite small. And the starting point for the study differed between the institutions. So Cleveland was using red light, Cincinnati was using blue, and the Franklin Park Zoo was using sort of just white light to illuminate their exhibits during the dark phase. And so we experimentally changed the lighting for the dark phase based on the starting condition, and then we left the light phase unchanged. So at Cleveland, we did a within subjects design looking at the effects of changing red to blue and then back to red, so an ABA design. And then we kind of did the inverse of this at the Cincinnati Zoo. And we measured salivary melatonin as a biomarker for circadian disruption. And just to give you a little idea of what the process looks like, that's a pygmy slow loris chewing on a saliva swab. Their podos and lorises were trained to do this voluntarily, and then you just centrifuge off the saliva. And we did tons of validation experiments for this that I don't have time to discuss. But we were able to get saliva to look at this hormone melatonin as a biomarker for circadian disruption. So quickly, the results. We found that the activity budgets during the dark phase for podos at the Cleveland Zoo, the main difference that we saw experimentally was here in the moving or locomotor behavior. So under red lights, there was relatively high. When we changed the lights to blue, locomotor behavior went way down. And when we changed them back to red, the phenomenon reversed itself. And we saw the same trend in the pygmy lorises that we measured as well, where, again, you see this decline in movement behavior followed by a recovery after the return to red light. What's really interesting is when you look at the data from the podos at the Cincinnati Zoo, where they were starting on blue light, and you see the sort of opposite trend, where now we have blue light. When we changed it to red, they started moving around a lot more, and then it subsequently declined after changing it back to blue. Now, we also did look at melatonin levels in the podos, and we did not find significant differences at the Cleveland Zoo. We did find significant differences at the Cincinnati Zoo, but we think that those are pretty much attributable to one individual that moved from a dimmer enclosure to a brighter one. And so we replicated this experiment at the Franklin Park Zoo with a podo, experimentally moving him from a dim blue exhibit to a bright blue exhibit. So you can see that his melatonin levels are highest under red light, lower under dim blue light, and lowest under bright blue light. So it appears that both within and between subjects, we were seeing really more of an effective intensity rather than light color, and probably there are separate sort of dose response curves for melatonin depending on wavelength that need to be sort of worked out. So generally, we did conclude that animals are more active under red light, that blue light may mask locomotor behavior, but we didn't really necessarily see circadian effects of lighting design, but I think further testing is needed, and it's possible that animals living in brighter exhibits were chronically melatonin suppressed. I had the opportunity to apply some of this research in West Java. I was working on a grant as a postdoc studying the evolutionary ecology of venom in the slow lorises, and I just happened to get to Chickamauga Wildlife Center right after they had rescued a group of 78 animals from the pet trade. These are all greater slow lorises, and you can see the conditions that they came in under. And so one of the first things that I did when I got there was change their nighttime lighting to red. They were doing all their husbandry activities under bright white lights, and then noticing that the animals were very active during the day as if they weren't very well regulated circadian-wise. So we changed their lights to red, and we saw all kinds of really interesting predatory behaviors. So this is a slow loris under red light in West Java, tongue flicking, just like a little snake at a millipede, sampling probably the chemical information from that creature and ultimately deciding not to eat it. And so, not only was this good welfare making this change, but it was also good science, because this is something that we, wouldn't have seen most likely under different lighting conditions. And so that's my last sort of soapbox point anyway, is just to really push for more of this type of collaboration between zoos and sanctuaries. I think sanctuaries and range countries have a lot to tell us about the behavior of animals that are wild caught. And we have so much to share with them that we've learned about the captive husbandry of animals. And I think there should be, I hope there will be many more collaborations of that nature in the future. And these are all my collaborators. Thank you.
Thank you, Grace. Questions for Dr. Fuller? Way up there. Go ahead.
Hi, Don Moore from National Zoo.
Hi.
So there are an awful lot of light shows in zoos these days. Hello? No?
I can hear you fine.
I'm worried about the camera. Are we worried about the camera?
Yeah. Okay. Yeah. Our tech guy's shaking his head, yes. So there are an awful lot of special events and light shows, and we're coming up to the season of holiday lights. And I can relay an anecdotal issue with a giant panda for you later on. But animals are shifting their breeding seasons apparently under this incidental light. And so that's all anecdotal. How would you suggest that we go ahead and study that?
Well, I think that, lighting is something that we can control relatively easy in zoos. So it's a great opportunity to do research in comparative research, especially with the wide variety of species that we have here. I mean, we can experimentally change the lights like I did. It's a pretty simple, cheap manipulation that potentially actually has great impacts on welfare. And I think that, we need to be more conscious of light and light bleed, especially in public events maybe that are occurring at nighttime in animal areas, and think about how that affects the welfare of our animals when we're disrupting their circadian rhythms. I mean, probably how you feel if you're not sleeping well. You can imagine the types of negative effects on your health that these kinds of things might have.
Hi there, that was very interesting. As a non-zoo person, I don't know if I'm the only one who's wondering this. I was just wondering, for nocturnal animals who are kept in zoos, are they ever able to get outdoor access, and how is that done when they're on this sort of opposite schedule?
So it's really challenging because, I think ideally you always want to give animals access to outdoors, and a lot of times they aren't because of the necessity of creating an artificial lighting regimen. Here at the Detroit Zoo, we don't house very many nocturnal species, but they do have access to the outdoors. But I know that it is potentially some challenge, because they're not as visible to visitors and they're certainly not as active. Luckily, we have night keepers, but from a care perspective, you want to have your animals active when your staff is there so that you can monitor their behavior and their well-being. So it's not good to have animals on a natural light regimen if you can't observe them, So I think these are really challenging issues for zoos that we haven't really figured out yet.